Now we are taking up the third discovery, that is the discovery of neutron. So after, how neutron was discovered, it was found, see, the electron was discovered and similarly the proton was discovered. So it was found that atom consists of nucleus, as we all know, and in nucleus there is proton and outside there is electron, right. So that means before the neutron was discovered, and this is the assumption I am telling you, that how the scientists assumed this and what led to the discovery of the neutron. So that means according to them at that moment it consists of positive and charged particle proton which lies in the nucleus, and it consists of negatively charged particle electron which lies outside the nucleus. We know electron has almost negligible mass and proton has a huge mass as compared to the electron, that is this thing, the 1.6 into 10 raised to power minus 27 kg, right. So that means the whole mass of atom must be due to the proton only, the whole mass of atom must be due to the nucleus only, right. So because the nucleus has the proton, that means the mass of an atom should be equal to the number of particles present in nucleus, that is the protons which is present in the nucleus, and we know the number of proton is equal to the atomic number, but this doesn't happen as such. In any case of atom, mass of atom is never equal to the atomic number. It is always more than the atomic number. So this led to the discovery of neutron, and the scientist who made this discovery was Chadwick. He was the one who took the main criteria into the consideration, and just was you can say he was running behind that what is the reason behind that the mass is not equal to the atomic number, it is not equal to the number of protons. There was a certain, you can say, he had an idea in mind that there is something in the nucleus that may exist in the nucleus which contribute towards the mass but not the charge. So he made a discovery, he discovered a particle, accidentally he discovered a particle by carrying out the fission of some heavy nucleus. He saw a particle which was emitted called as neutron, a particle which has almost the mass equal to the mass of the hydrogen, that is 1.6 into 10 raised to power minus 27 kg, but no charge. So he named that particle as neutron, that is the neutral particle. So it was, you can say, the position of neutron was justified that this kind of particle is present in nucleus which contribute towards the mass but not the charge. Because as we know the atom is electrically neutral, that means number of proton is equal to number of electron. So the particle must be a neutral particle which is contributing in mass but not the charge, and it happened, and it was proved also by, see, I am taking an example like in case of helium, the atomic number is 2. That means number of proton is 2. So that means its mass number should be equal to 2. But however, when it was found, its mass number was equal to 4. So that means it was not equal to the atomic number. That means there exists some particle which is contributing in case of mass, and that was called as neutron. So in helium, we write helium as 4 and 2, that means atomic number 2, number of protons are 2, but mass number which is equal to the sum of protons and neutrons is 2 plus 2. That is why the mass number comes out to be 4. So this is how the neutron was discovered. Now you all know that how the subatomic particles were discovered, the electron by J.J. Thomson, and I'll just brief you the charge mass, because you need to remember those charge and mass carefully while using the in the numericals and all. You need to know that what is the charge and mass actually. It won't be given. You have to remind in mind that what charge does the electron has or what charge does the proton has. So electron has, the charge on electron and proton is of same magnitude, 1.6 into 10 raised to power minus 19 coulomb, but the nature being different. Electron is negative and proton is positive. So write the magnitude in negative for the electron and positive for the proton. And when we talk of the mass of the electron is 183.7 times less than the hydrogen atom, and the mass of proton is approximately the same as the hydrogen, that is 1.6 into 10 raised to power minus 27 kg, as we have done before in E. Goldstein experiment. And in case of neutron, similarly the mass is same as that of proton, same as that of hydrogen, but no charge. So just keep in mind the electron, proton and neutron, as they play a very important role whenever you will study on some atomic level. So you will get to know that what the charges are actually.